Section 12.2 is going to talk about chords and arcs and their relationships. So how do we use these congruent chords, arcs, and central angle? And how do you use perpendicular bisectors to a chord? All right, so to start off, let's define what is this thing called a chord. A chord is a segment that goes from one side of the circle to the other. All right, now the most sought after, I guess you could say, chord that exists, or the most specific one, would be a chord that goes through the center of a circle, which is also known as the diameter. All right, so when I have this chord, a lot of different things start to happen. Okay, for example, Theorem 12.4 says within a circle or congruent circles, congruent central angles have congruent arcs. All right, so let's start right there. Let's say that I have this central angle in this particular circle. All right, and I have another central angle that is in this circle, forms something like this. All right, and what this theorem is saying is if this angle is congruent to this angle, all right, then their corresponding arcs must also be congruent. Conversely, if the arcs are congruent, the angles must be congruent as well. All right? So if the angles are congruent, their arcs must be congruent. And again, remember, we're dealing with a central angle. And if the arcs of central angles are congruent, then the angles must be congruent. Let's take a look at Theorem 12.5. It says within a circle or congruent circles, congruent central angles have congruent chords. Okay. So let's use that same kind of example here, where let's say that we have a central angle like this, and let's say that we have a central angle that's very similar in its drawing. It maybe looks something like this. All right. Now, if I know that this central angle is equal to this central angle, then what happens is these two central angles have what is called a chord. The chord goes from the endpoints of the central angle and connects them. All right, so we have one for each one of these central angles. If the angles are congruent, then these chords have to be congruent. All right, so quick review here. If you have congruent central angles, what the heck is going on? All right, if you have congruent central angles, then you have congruent arcs. If you have congruent central angles, then you have congruent chords. All right? And the third one now says if you've got congruent chords, you have congruent arcs. Holy cow. So let's take a look at what this one's saying. All right, so this one is saying if you have an arc, let's say that looks something like this, and you have another arc, let's say that looks something like this. And I'm trying to draw these chords, to be congruent. If these two chords are congruent, then I can conclude that their arcs must also be congruent. All right, so let's try to look at this in application. Oh, I forgot we got one more thing. And this theorem says, within a circle or congruent circles, chords are equidistant from the center or centers are congruent. Chords that are equidistant from the center are congruent. Well, let's take a look at what that one now is saying. Let's say that I have this chord right here. And let's say, similarly, I have a chord that goes like that. And I know that these two chords are congruent. Now, in the center of the circle, I know that I have this point right here. What this is telling me is the distance, the equidistant is the key. The distance from the center to this chord, which remember, has to be formed by a right angle if we're measuring distance, must be the same as the distance, whoa, that was pretty bad. The distance from the center to that chord. All right? So not only do these things have to form right angles to show the distance, but they also have to be congruent to one another, provided that these chords were congruent. Okay? So let's take a look here. The other thing that it does also, just to throw this in, it's going to be the perpendicular bisector of that chord as well. All right, so let's take a look at the examples now. In the first example, we have to find x right here. Okay? I know that if this side is 7, then this side is 7. All right? In other words, this chord is getting bisected. So I know the length of that chord is 14. These two measurements right here tell me that those two chords are equidistant from the center. If the chords are equidistant from the center, then I know that x has to be equal to 14. It's literally that easy. Okay? So let's take a look at this one now. All right? I notice that I've got chords. I've got the distance from a chord to the center. And I know that the measurement of this chord up here is 15. Which tells me because this chord and this chord are congruent, I know that I have congruent chords. If the chords are congruent, then the distance from the chord to the center must also be congruent. Or in other words, x has to be equal to 8. All right, so let's take a look at this one now. All right, I know that the distance from the center to this chord is 3.5, and it has to be the same in this other chord as well. All right, now because those two distances are the same, I know that the chords also have to be congruent. So if that side's 5, that side's 5, which means x is going to have to be equal to 10 units. All right? Another theorem to throw in here. It says, in a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. All right, so let's take a look at this. Let's say right there's the center of the circle, and let's draw a diameter. All right, so we have a diameter that goes right through the circle. Now, we have this diameter that is going to be perpendicular to this chord. All right, so let's draw that perpendicularity right there. All right, if this is occurring, then I know this has to be true. I know that this piece of the chord and this piece of the chord have to be congruent. And I also know this piece of the arc and this piece of the arc have to be congruent. So a diameter will split that chord, as long as it's perpendicular to the chord, it will split it into two equal pieces, and it will also split the arc into two congruent pieces. Theorem 12.9 says, if a diameter bisects a chord that is not a diameter, then it's perpendicular to the chord. All right, so a diameter, there we go. Here's my diameter. If the diameter bisects a chord that is not a diameter, then it's got to be perpendicular to the chord. So in other words, if a diameter cuts through a segment like that, if it cuts through it and bisects this chord, then it must be perpendicular. All right? So again, let me kind of point that out. If I have a diameter that goes through a chord and bisects the chord, I can conclude that perpendicularity must occur. All right, one more theorem here. In a circle, the perpendicular bisector of a chord must contain the center of the circle. Here's what this is saying. If you have a chord, let's say here's a chord, and you have a perpendicular bisector of this chord. Sorry, my drawing's not perfect here. But if you know that this is a perpendicular bisector of the chord, then this thing that you just drew must go through the center, which now means that this must be a diameter. All right? So let's see how this is applied now. Okay? We have this picture here. In this picture, I notice 20 is the length of the diameter. I know 16 is the length of the chord, and they want me to find this segment right here, which is the distance from the center to the chord. All right, so if 20 is a diameter, then I know that this side is 10 and this side is 10. If 16 is the length of the chord, and I know a perpendicular is being formed here, then I know this has to be 8 and this has to be 8. In order to find x, I want to focus in just on this triangle here now. All right, so I know to find x, I'm going to use Pythagorean theorem that says 10 squared is equal to x squared plus 8 squared. Or 100 is equal to x squared plus 64. Subtract 64, I get x squared is equal to 36, or x is equal to 6. All right, so the distance from the chord to the center is going to be 6 units. Let's look at this next one now. All right, they want me to find the measurement of x here, which is a radius. All right, is this radius the only radius that exists in this picture? No, as we've learned before, we have an infinite number of radii, okay? So the first thing that I would do is say, hey, I want to make the radius be that piece instead. It's still going to have a measurement of x because all radii are congruent. I know that if this chord is 8, then this side of the triangle has to be 4, and there's the triangle I have to solve in order to find x. And in this case, x is going to be the hypotenuse. So x squared is equal to 3.6 squared plus 4 squared, or x squared is equal to, let's use the handy dandy calculator here, 3.6 squared, 12.96, plus 16. So x squared is equal to 28.96. And did it say anything in the directions about rounding? Yeah, it said round to the nearest tenth. All right, so now to find x, I'm going to take the square root of that. So let's see, I need to add 16. All right, and then take the square root and round to the nearest tenth. So that would be approximately 5.4 units. All right, one more of these. Just take a look at this one. So again, I know this is the hypotenuse of this triangle, or the radius. I know the 6 represents the distance from the center to the chord, and they want me to find the measurement of the entire chord. Now, I'm going to call this piece right here y. I know that x is 2 times y because that perpendicular bisects the chord. All right, so I'm going to use the Pythagorean theorem to first find y. I have 12 squared is equal to y squared plus 6 squared, or 144 is equal to y squared plus 36. All right, so that means that 108 is equal to y squared, or y would be equal to the square root of 108. All right, now that's not what they asked me to find though. Now I'm going to find x. I know that x is going to be 2 times the square root of 108. And now I'm ready to go to my handy dandy calculator to figure this out. So I pull up the calculator and I take 2 times the square root of 108 and get that answer, and it'd be 20.8 units is the length of the chord. All right. Hope this helps. Make sure that you do Math Excel 12.2 and have that, get that to 100%.